Hi everyone. In this video, we are going to look at how to do divisions with fractions. So we have several learning objectives. Basically, they all involve how to do division with fractions, including regular fractions, mixed numbers, and rational expressions. A rational expression is just a fraction, but the numerator or the denominator or both are polynomials. So let's look at these learning objectives one by one. First, we need to know this concept or terminology called reciprocal. Basically, the reciprocals are defined as two numbers when they multiply together, the result is one. For example, 2 and 1/2, these two are reciprocals because they multiply together equal 1. In general, if you have fraction a over b and the other one is b over a, when they multiply together, you get ab on the top, you get ab on the bottom, anything divided by itself is 1, right? So these two are reciprocals. In other words, to find a reciprocal is very simple. If you have fraction, just switch these two numbers and then you get a reciprocal. Or if you have a whole number, just put 1 on top of that whole number, you get a reciprocal. So 1/2 is reciprocal of 2. So it's very easy to find the reciprocal of a given number. Now let's look at some examples. Find the reciprocal. This is a fraction, we just switch it. So reciprocal is 4 over 3. Right? Super simple. And the second one, 1 over 5. I switch it, which is 5 over 1. But 5 over 1 is just 5, right? So the answer is 5. The final answer is 5. Now, third one is whole number. We just put 1 on top of that whole number. And that's it. This is a reciprocal of 6. So when they multiply together equal to 1, right? That's called a reciprocal. And let's look at what's on the next page. Oh, we do have another one. We got this a negative 5 over 7. We need to find the reciprocal of this number. Reciprocal won't change the sign of that number. So we just multiply together equal to 1. So we just switch these two numbers. We get negative 7 over 5. And hopefully this makes sense. When these two multiply together, negative times negative is positive. And 5 times 7, 35 on the top. 7 times 5, 35 on the bottom. And anything divided by itself is 1, right? We still get a positive 1. Remember, reciprocal is defined as two numbers when multiplied together equals 1. 1 means positive 1. Now, this is your first set of exercise questions. All of the answers to the exercise questions are in the comment area below the video. So now let's look at how we divide, how to divide fractions. Basically, this is a process how you do division with fractions. Basically, you just change the division operation to a multiplication. Then you do it as a multiplication problem. So we already learned how to multiply fractions in the last video, right? Mm-hmm. If you're not familiar with how to multiply fractions, and you watch that video first before you watch this division video. Now let's look at a few examples here. The first one is 5/8 divided by 3/4. So the general process is that we keep the first number unchanged and change the division to multiplication. Then you change the second number to its reciprocal. So regardless the first number is whole number or fraction, you just keep it unchanged. So 5/8, change division to multiplication, and change the second number to the reciprocal by switching these two numbers since it's a fraction. Now we can do these two are equivalent, okay? These two are equivalent, which will give you the same result. Then we do it as fraction multiplication problem. And we are going to simplify between these two. both sides can be divided by 4. Now nothing else can be simplified. Now we can multiply them together. 5 times 1 is 5. 2 times 3 is 6. Yeah. By the way, I like to mention this. When we have this rule to do division with fractions, we change division to multiplication and change this fraction to its reciprocal and then do it as a multiplication. This process is not because this number that you divide by is a fraction. It's not because of that, even though it is a fraction. We change division to multiplication is because we have this relation between division and multiplication, regardless what number you use. I'll give you an example to demonstrate that. So 10 divided by 2 equals 5. That's whole number division, right? I can still apply that fraction division rule here. Keep the first number unchanged, change division to multiplication, change the second number to reciprocal. 2 reciprocal is 1/2, right? What is half of 10? 5. You still got same answer. In other words, this change division to multiplication and then you change the second number to its reciprocal is because the relation between these two operations is not because we have a fraction in the division, okay? The reason we use this method for the division by fraction is because otherwise many people will make a mistake. It's not because it cannot be done without changing to multiplication, okay? Okay, now let's move on to the next example. Negative divided by negative is positive, so we don't need to carry over this negative signs because we already know the result is positive. So we just keep the first number unchanged. Change division to multiplication, reciprocal. Now we do it as a multiplication problem. 4 and 12 can be simplified. Divided by 4, divided by 4. Now we get a 1 on the top. 9 times 3, that's 27. 1/27. So that's our final result. This is an exercise for the division with fractions. Now let's look at some examples to do division with mixed numbers. So generally speaking, you cannot do division with mixed numbers directly. Whenever we have mixed number in the division, we want to change that mixed number or mixed numbers to improper fraction. And then we continue to perform the division. So let's look at our first example here. And we change both to improper fraction. Multiply, add. 5 times 8, 40. 40 plus 2, 42. So we have 42/5. Then divide by, I try to do it step by step. Multiply, add. 2 times 4, 8. 8 plus 1 is 9. So 9/4. Now we can change division to multiplication, right? Remember, always keep the first number unchanged. Change division to multiplication. Then switch the second number to get reciprocal. Now we do it as a multiplication problem. So 42 and 9 both can be divided by 3. Divided by 3, you get 14. Divided by 3, you get 3. Anything else we can simplify? No, nothing can be divided by 3 on the top, and nothing on the top can be divided by 5 either. So that's simplest form. We got 15 on the bottom, we got 56 on the top. 14 times 4, 56. Usually, if you have improper fraction form as a result, you want to change it back to the mixed number format. So 56 divided by 15, that's 3, because 4 would be 60. So let's do the division on the side. So it's 3, you got a 45. So remainder is 11. So you got 3 and 11/15. That's the result. Okay. Move on to the next page. We have two more examples. And this is a mixed number divided by another mixed number. This kind of fraction, this whole thing is big fraction. And this kind of fraction is called a complex fraction because you have a fraction as a numerator or a fraction in your denominator or both on both sides. Okay, either way, it is called a complex fraction. Now this is equivalent to -3/7 divided by 3 1/3. They're the same thing. This bar is called a division bar. Now let's change each number to the improper fraction. So -5 times 7, 35 plus 3, 38. Now 3 times 3 is 9 plus 1 is 10. So divided by 10/3. Now change division to multiplication. I get 38/7 times negative times 3/10. Now apparently 3 and 7 cannot be simplified. And 10 and 38 at least both can be divided by 2 because both are even numbers. Even numbers, they all can be divided by 2. So I get 5, I get 19, and nothing else can be simplified. I get a negative result. And 19 times 3 is 57, and this is 35. So 57/35. This is improper fraction, we do division. There's only 135 in 57 because 235 will make 70. It's bigger than this. So I get 1. What is remainder? Do a subtraction. So 22 is the remainder. 22/35. So that's our result. It's just a matter of practice. Everybody can do that. So make sure you do enough exercise after you understand this process. Now, the next one, just go through the same process and change the mixed number into improper fraction. This is 20 plus 3, 23. Divided by 3/10. So now we keep the first number and we change division. Oh, we already changed. Sorry about that. This should be division. We change division to multiplication and switch the second number to get the reciprocal. Now, 23 is a prime number. It cannot be divided by any number, so we cannot simplify that. But 10, 5, both can be divided by 5. Now multiply them together, we get 46/3. And let's do division. Actually, it's 15, but let's do the division. Divided by 3 is 1, get 3. Remainder is 1, 16, that's 5. 15, remainder is 1. So quotient is 15, and remainder is 1. 15 and 1/3. So that's last example for this part. Now this is your third set of division exercise, division with mixed numbers. Now let's look at our next learning objective. We're going to do division with rational expressions on the next page. So we just have this one example because they are really very similar. And nothing really different. We just keep the first one unchanged. 6a cubed b 35c to the 4th power. Change division to multiplication and switch the second number and 15a. Now this is even easier actually. So between 14 and 35, they all can be divided by 7. By the way, if you have larger numbers, you cannot see what is a common number that can divide into both numbers. Always try prime numbers, because as long as they have common factors, all of those common factors can be factored into prime numbers themselves. So 7 can divide into both. So divided by 7, we get 2, divided by 7, we get 5. Anything else we can do? Apparently between 6 and 15, we can divide by 3. Say 3 is not a prime number. That's 2, and that's 5. So in terms of numbers, we get a negative result because negative divided by positive. In terms of number, we get 2 times 2, 4 on the top, 5 times 5, 25 on the bottom. Right? This is just for the number part. Now let's look at the letters. We have 3 A's on the top. 3A, I mean A times A times A. Okay, 3A. Now you have 1A on the bottom. You cancel 1, you still get 2 more left, right? 2 more left, and that is A square. It's like this. That's A cube means A times A times A. You have 1A on the bottom, cancel, you still have 2 left on top. Now let's look at C. We have 4 on the bottom, we have 2 on the top. These 2 cancel, you still get 2 left on the bottom. Yeah, that's the final answer. Actually, it's very easy to do. These letters are easier to deal with than numbers, right? Okay. Now, this is another set of exercise problems. Make sure you do enough exercise until you are really familiar with this whole thing. Now, next topic, let's find the square root of a fraction. Now, basically here, there are 2 approaches, at least in this pre-algebra course. First, you want to try to take a square root of the numerator and the numerator separately, if they can be, do square root operation on them. Or if you cannot do square root on numerators and denominators separately, try to simplify the fraction first, then look at it again to see if you can do square root on it. So let's do that. Examples on the next page. So we have 2 examples. We do it one by one. The first case is that either of the 2 numbers is a square of some other numbers. That's why we can take them out one by one. Square root of 25 is 5. Remember, square root means a number that when you multiply by itself, you go back to the original number inside the square root operator. And square root of 36 is 6, but it's below the bar. So that's it. How do we know this is correct? You can double check. You do square, because square is a opposite operation of square root. When you multiply by itself, you get 25 over 36, and that is the number inside. So you know it's correct. Now, this case is the second scenario where you cannot do square root of 45 without getting a decimal. Same thing for 5. So we will try to simplify them first. So 45 divided by 5 is 9. Square root of 9 is 3. And 3 times 3 is 9. In the real life, we don't just have this situation. We have other situations. For example, you have a fraction that cannot, the numerator or denominator is not a square of any number, so you cannot take them out separately. And you cannot simplify them either. So what do we do with those? So you're going to learn those in the future algebra courses, a little bit higher level. Now, this is exercise number 5. Exercise number 5. Now, next one, we are going to look at solving equations involving fractions. Remember, this whole thing is under the big picture that we do divisions with fractions. So this equation, the process will involve dividing with fractions. So 3/4 times x equals 2 and 5/8. We need to find x. X means 1x. We already learned general approach by solving an equation because which is this. We want to get rid of any number on the same side with x. Since we only want to have x by itself, the other side is number, then we call it solution to the equation, right? So we need to get rid of 3/4. How do we do that? Basically, I'm going to do this twice, by the way. Anything divided by itself is 1. That's how we get 1x. For example, 2x equals 10. How do we solve it? Divided by 2 on both sides. Cancelled, you get 5. And you know 5 is correct answer. 2 times 5. 2 times 5 equals 10, right? we can do the same thing. So suppose we divide by 3/4 on both sides. And this side, we just write it this way, divided by 3/4. So this two cancel, anything divided by itself is 1. So x equals this number divided by 3/4. So now I can change this to improper fraction, 16 plus 5, that's 21 over 8. And then I can change division to multiplication and switch to second number. Now I do it as fraction multiplication, right? Cancel 4, get 2, cancel 3, I get 7. So we get 7 times 1 on the top and 2 times 1 on the bottom. Change it back to mixed numbers, this is 3.5. 7 divided by 2, there are 3 2s in it, right? 3 2 makes 6, so remainder is 1. Or you can do it a little bit more efficiently, just a little bit. Remember, our goal, no matter what we do, our goal is the same. We want to have this x by itself. We want this number to become 1. One way to do it, to make it 1 is divided by itself, right? Now we have another way to do that. Remember, what is the definition of reciprocals? One reciprocals multiplied together equal to 1, right? So we can multiply reciprocal of it to make it 1. So that's a 4 over 3. We have to do it on both sides whenever we do any operation on the equation. So this becomes 1, right? 3 canceled, 4 canceled, with 1. And guess what? This is exactly the same situation, right? This number times this. I just need to change that to improper fraction. So this is exactly the same thing. So we don't need to redo that. This will be 3.5. So either way is okay. Essentially, there's no fundamental difference. When you divide by fraction, it's equivalent to multiply by the reciprocal. Basically, it's like saving 1 step. And exercise number 6, you have 4 equations to solve. Now, next one, example 7, solve and check. So again, our goal is to have m by itself. How do we do that? We always want to do opposite operation to cancel the number we don't want. M and 5 are connected by this division, divided by 5. What is the opposite operation of dividing by 5? You multiply by 5. So that's what I do. Opposite operation, this to cancel. If you don't see this to cancel, you can always put a 1 on bottom of any number, because anything divided by 1 won't change anything. So now this is numerator, this is denominator, this two can cancel. So m just equals this two multiplied together. Now we change this to improper fraction, 3 times 10, 30, 31 over 10, negative times 5. Again, 5 and 10 can be simplified. You can imagine a 1 on the bottom, right? In other words, whenever you have a whole number, you treat this whole number as the numerator. So cancel, get 1, you get 2 left on the bottom. 31 divided by 2, that's 15. 15, 2 and 2 make 30, right? And you still have 1 left, remainder, so 1 over 2. Negative 15 and a half. Now, solve and check, right? Let's check. So m equals this number. That means if I plug in using this number divided by 5, I should get this number on the right side, right? So let's do that. Next, 15 divided by 5. This one equals negative 31 over 2 times 1/5. Turn the division, multiplication, and switch it. So now we got negative 31 over 10. So divided by 10, you got a 3, right? 31 divided by equals 3. 3 times 10 is 30, remainder is 1. So negative 3 and 1/10. That's the exact same number. Right? That's the exact same number. So the next exercise problems here. And another learning objective. This time we're going to solve some applications involving division operations. So let's look at our first example. A board is 35 3/4 inches long. The board is to be cut into pieces that are each 6.5 inches long. How many pieces can be cut? So we don't know how many pieces can be cut. So this scenario is super simple. Everybody understand the information in this description. Now here's the thing: when you solve application problems, try to represent the information in the description. Don't focus on calculation part. This is true. The higher you go, the easier. I don't take it back. Not the easier. The higher you go, the more efficient to solve a given application problem if you focus on representing information instead of doing calculations, instead of focusing on numbers. So how do we represent information? We just cut this whole piece into pieces. This whole piece is given 35 3/4 long. We cut them into pieces. We don't know how many pieces. That's our x pieces, represented unknown using variables. But we do know the length of each piece, which is 6.5 inches. So what does it mean? You have so many pieces, each one 6.5. You multiply this many pieces, you get a total length. For example, if you have 5 pieces, each is 6.5, you will multiply by 5 to get a whole thing, right? Again, we write something, represent something that is true. That is your equation. There's no magic in setting up the equation. Just represent something that is factual. Let's do that. 6.5 times x represents number of pieces, must be equal to the total length. And that's why we have this as an application example. We have to divide by this number to get x, right? So anything divided by itself is 1. We need 1x. So x equals, let's change both to improper fraction. 35 times 4, that's 140, 143. Divided by, this one is 13/2. 13/2. Now change division to multiplication and change the second number to the reciprocal. 143/4 times 2/13. And 143 divided by 13 is 11. And we can verify that by doing division. 143 divided by 13. That's 11. So canceled. 11. 2 and 4 canceled. You got 2 left on the bottom. So you got 11 over 2 on the bottom. So that's 11 over 2, 5.5. Is that right? Let me 140, double check quickly. 35 3/4. I just want to make sure I don't read the information wrong. Inch long. Yeah, that is right. 13/2. This 143/4. That's correct. And 13 on the bottom, 2 on the top. Cancel, we get 2 and 11. Yeah, everything is right. So 5.5 pieces. I just want to make sure this fraction result actually is the correct one. Now let's look at example B. Similar, just a different story here. And when I say similar, I mean the way we solve it is very similar. The circumference of a circle is 20 3/7 inches, and find the radius. So we know the radius formula, the circumference formula of circle is 2 pi r. So circumference equals 2 times pi times the radius. We are solving for radius. Apparently, we need to divide by 2 pi on both sides to get radius, right? So we set up equation because of this, according to this. So this is the circumference, 20 and 3/7 equals 2 times pi times radius. We radius we don't know, we solve it. But here, since we are working with fractions, we don't want to work with decimals, and you can replace pi with a approximate, which is fraction 22/7. This is very close to pi. Pi is 3.14 something. So 22 divided by 7, that's 3.14 something. So we replace pi with this. So let's change this one to improper fraction first, because we know we need to change that anyway in the end. 143/7 equals 2 times 22/7 times r. Now 22 times 2 is 44. 143, that's good news actually, over 4 over 7 equals 44/7 times r. So whenever you have same thing on the denominator or same thing on the numerator, you can cancel them. And the way to cancel that is this. You can always do the same operation on both sides of the equation. Imagine I multiply 7 on both sides. Guess what? This will cancel, this will cancel. That's why whenever you have a common factor on the same side and the equation, you can cancel it. So we just have this 144 equals 143. 143. When I look at this number and I need to write this number, write down this number, that's what happened here. 143 equals 44r. Right? Yeah, radius equals 143 divided by 44. And change it to mixed number, we have 3. Let's use a division. This division by hand. But later on, I'm going to show you how to use a calculator to do this thing super fast without going to this word size. So let's say 143 divided by 44, you get 3, you get 132. So remainder is 11. So we get 3 and 11 over 44. So now I'm going to show you how you use a calculator to do this division and still get this fraction. So let's do that. We get 143 divided by 44. 143 divided by 44. You got 3.25. 3.25. Yeah, 3.25 exactly. The reason is this 11 over 44 can be simplified. Divided by 11 on both sides, you get 3 and 1/4. That's 5.25. Now here's the thing, how you get this fractional part. After you get this decimal result, subtract whole number part, get rid of whole number. -3 equals. So now we only have decimal part, which is the same as this part. How do you convert it to this side? How do you convert to 1/4? So basically you multiply the original number actually. The original number you divide by, which is 44. Divided by, multiply by, sorry. Multiply by 44. What do you get? You get 11. In other words, when you divide by 44, remainder is 11. Use the original right? Then you go there to get this part, then you can simplify it. So this is good for any number to convert it to mixed number. And pretty much this is it for this video. And if you have any suggestions, post it in the comment area. See you in the next video.